Hi, my name is William Wheeler Kleinberg, and along with my peers Cameron Keenan, Casey Crow2, and Ben Resick, we modeled 1 meter sea level rise in the Georgia coastal ecosystems. Our research question is focused on the Georgia coastal ecosystems. The goal of our research was to see how 1 meter sea level rise would impact the GCE in regards to gains and losses in water, marsh, and upland covers. We used Tercet's macromodel to create a scenario in which by 2100 the sea will have risen by 1 meter. The Georgia coastal ecosystem that was focused on is located at the GCE6 site on the image on the right hand of the screen. These ecosystems are home to a diverse array of both flora and fauna. The GCE is studied in order to observe how the coastal ecosystems will change over time, as well as looking at how climate and human activities will cause change to the GCE.
These are the methods we use in our LCM project. This is the macro model that we created for our scenario to model sea level rise of 1 meter. And these are our data inputs. The GCE 2013 land cover map on the left shows the land cover of the study area at the start of the scenario, while the GCE elevation in meters on the right represents our sole driver variable for the scenario, which is determined where all growth, loss, or persistence of the 3 land categories occurred. This is our reclassification. We decided to use a simple reclass of the 3 land cover categories based on elevation. We assumed that if sea level rose by 1 meter, all areas at 1 meter or below in elevation would be submerged in water. Furthermore, we assumed based on our research that given enough time, the marsh would increase by 1 meter in elevation as the water rose by 1 meter, because the land would be saturated with enough water for marshland to develop.
These two maps each display the change in land cover for the GCE for 2 time points. The map on the left displays historic change from 1942 to 2013. The map on the right displays our model change from 2013 to 2100. These two intervals of time are roughly equal in length, but there is far more change of land cover type in our modeled scenario. This graph compares historic change in land cover to our modeled change in land cover by area. Our modeled scenario represents a clear departure from historic patterns, with the majority of the GCE area being covered with water by 2100.
So, in conclusion, in the event of a 1 meter sea level rise between 2013 and 2100, we project major declines in marsh cover that transition to water and only a minimal gain of marsh into upland categories. And finally, thank you to Professor Robert Pontius and the teaching assistants Kyle Peksuk and Maria Ballas for their help throughout the semester and on this project. Also, a huge thank you to Christine Burns for supplying us with the relevant data to carry out this project on the GCE. For any questions, please email us via the email addresses below. Thank you.